9.4 Solving inequalities by using graphs. In this section, we'll talk about how to solve inequality by using the graphs. You know inequalities can greater than a value, smaller than a value, or greater or equals to a value, or smaller or equals to a value. So how to do it? Let's see on your textbook page 24. Actually, we can follow two steps. Let's have a look. For example, now we have a curve y equals to x cubed minus 7x. Okay, like this. This is the graph of the curve. Okay, graph of the function. Okay, now I want to solve x cubed minus 7x greater than negative 6. Greater than negative 6. So step 1, try to draw the horizontal line y equals negative 6. That means this value. So draw a horizontal line y equals 6 on the graph of the function like this. So here y equals to negative 6 straight line. Step 2, from the graphs, find the interval of x. Okay, that means now the curve greater than negative 6. That means if you show that, okay, or know that this part greater than negative 6, right? So the curve greater than negative 6 will become this part only. This part only. The curve greater than negative 6, that means this one. So we need to find the corresponding interval of x. Okay, intervals of x. Okay, which corresponding value of y are greater than negative 6. So you see that from this point, so negative 3, right? This point is 1 and this point is 2. And after 2 or greater than negative 6, okay, then just know this part. And in between this interval, the curve greater than negative 6. Okay, greater than negative 6. So as a result, the answer x in between negative 3 and 1. Do you know why? Yeah, because this part is negative 3, right? So start from negative 3 to negative 1. However, not including the endpoints, because inequality sign here only greater than without equal sign. And one more, each square here or each unit here is 0.2. So we can see that this one negative 3.0 and 1.0. You can write like this, correct to the nearest 0.2. And also x greater than 2.0, because after this point all greater than negative 6. So the solutions are these two, x in between negative 3 to 1.0 or x greater than 2.0. You need to write as correct to the nearest 0.2. Okay, understand? So this one is the solutions. Okay, so let's see one example from the notes. 9.4a. Check point 9.2, you can do it by yourself first. Later on, we can check it all together. 9.4a. The figure shows the graphs of the function y to fx, that means this one, where x in between negative 2 to 5. So you see negative 2 to 5, the graph of the function here. Using the graph, solve the inequality fx smaller or equals to -1. Okay, so now here fx smaller or equals to -1, so you break it as y equal to fx and y equals to -1. That means draw the straight line y equals to -1. So here y equals to -1, right? That means like this, y equals to -1. So you can think it as, okay, smaller than -1. That means this part smaller than -1. Or you can use the symbol like in the linear programming, okay, smaller than, right? Okay, or equals to. As a result, from the graph, which part can you see? Yeah, this part of the function smaller than or equals to -1. So from the graph, the solution of the inequality of fx smaller or equals to -1 is x in between 3 to 5. This time including the endpoints, okay, because the inequality sign smaller or equals to, okay, so you have the equal sign this time. Okay, so draw the straight line first and then to check smaller or greater, okay, then which part of the function, and check the corresponding value of x. So x in between 3 to 5 as the solution of the inequalities. Okay.